Okay, good day, everyone, and thank you for joining us today once again. So this is Our Ladies Abuja, and we're glad you were able to join us this evening. So today we're going to be looking at structural equation modeling of the World Happiness Reports. So this is a follow-up webinar by Ridwan. So today we're going to be looking at a practical example of how to use structural equation modeling in R using the sample data set. So I'll use this opportunity. So today our agenda is going to be I'm welcoming everybody to the webinar today, and we're glad you're here once again. We're grateful. Thank you very much. So then I'll go ahead to introduce the organizers of Abuja. Our Ladies Abuja. Okay, we're one family. Okay, so I'm Bilikisu Olatunji. So I'm a data scientist here in Abuja with Business Data Laboratory. So, and we also have Abiodun Egwenu. She's a field epidemiologist and MR program manager with NCDC here in Nigeria, Abuja. So we also have Dr. Mabel Ajumobi. She's the Deputy Director and Assistant Chief Veterinary Officer with the Federal Ministry of Agriculture and Rural Development here in Abuja as well. So that's all that we have our esteemed members that are always supportive and making the group to grow more and more. And also our participants from all over the world. Thank you so much for joining us. So today we're going to be having Ridwan Adejumo. So he's a data scientist based here in Abuja as well with Business Data Laboratory. So he's a statistician by training. He has his BSc in statistics. So he's very passionate about using R, and he would like to share that experience with us and his knowledge using the structural equation modeling. So I would like to invite you now, Ridwan, to give your presentation. Thank you. Ridwan?
The sharing of screen, you have to enable it.
Okay, sorry. Okay, you can go ahead and try now.
Okay, hi everyone, good evening. So welcome to today's webinar where we're going to be talking about structural equation modeling of the World Happiness Report. So my name is Adejumo Sulema. I'm going to be presenting this particular webinar. So I'm actually a data scientist at a Business Data Laboratory, and I'm also a biostatistician at the Federal Teaching Hospital, Gombe. So the contents of today's presentation is, first of all, going to be talking about the World Happiness Report. So what is the World Happiness Report? What's it all about? So what does it entail and what does the data contains? So we're going to be talking about the World Happiness Report as the data sets we're going to be using. Then next, we'll be talking about the variables in the World Happiness Report. So these are the variables that are used in measuring happiness. So we're going to be looking at those variables and what do they entail, what are they, and how is it used in measuring, how is each variable used in measuring happiness of an individual or of individuals in a country. Then the next, we're going to be talking about structural equation modeling, also known as SEM. So what is structural equation modeling? What is it used for? In which areas do you apply structural equation modeling, and how do you also apply structural equation modeling inside the R programming language? Then also talk about the analysis of the World Happiness Report. We're going to be doing a practical analysis of the World Happiness Report. So I'm going to analyze the World Happiness Report using structural equation modeling and see what are the findings we can get using this particular structural equation modeling method. So though this webinar is actually like a practical follow-up of a previous webinar that I did, I think it was last 2 months, that's structural equation modeling. So you can actually check for the video on the Meetup channel. So this will just be like, okay, a recap of what I've already talked about in that particular webinar. So first of all, the structural equation modeling. So structural equation model actually is a statistical technique we use for analyzing relationship between latent and measured variables. You can also call these measured variables observable variables. So these are variables that we can actually observe. So it's just like saying in a lay term that the variables that are having columns present inside our data set. So we call those observable variables. While variables that we can't see or we can't measure, we call those latent variables. So these latent variables, a typical example can be something like anxiety, can be something like depression. So we have no particular way of measuring these particular items. But we know that when we have some details, such as a person's income, a person's relationships status, person's matter, these are things that we can also see are possible ways of measuring one's maybe happiness or one's anxiety or one's depression. So based on this particular example now, we can say now maybe the anxiety, the happiness or depression are latent variables. And we can also say the measure variables can be the income of someone, you can say the income of someone that's is our yearly income, is the person in a relationship. Maybe we want to try and know that, okay, people that are actually in a relationship are happier or something like that. So this is just what social equation model entails. So the reason of this kind of approach is because other techniques, statistical techniques, couldn't capture such variables that are not observed. So this is where social equation model now comes into place to be able to solve that particular problem. So we also have what we call explanatory factor analysis. So why explanatory factor analysis is coming into place is because sometimes before performing structural equation modeling, you need to perform explanatory factor analysis. And this means identifying the factors in an underlying set of observed variables. So sometimes you can have set of observed variables, and these observed variables can actually be under several factors. Let's say you have 20 variables, then these 20 variables can actually be grouped under 5 factors. So an explanatory factor analysis allows you to be able to know that, okay, from these variables that I have, let's say I have 20 variables now, how many factors can I get from these variables? So it's like you are creating a theory from your variables. We also have what you call confirmatory factor analysis, but that one also is also like just, you can see it's as similar as same, because in confirmatory factor analysis, you already know the factors that you are dealing with. So now we have 20 variables, and you already know from previous study that you are dealing with 4 factors. So there's no need for you to be performing an explanatory factor analysis. So sometimes you can even perform the explanatory factor analysis to try and know that, okay, is my model actually more accurate than that of the person that they have already done it before? So that means you compare it with the confirmatory factor analysis or and see which of the model is much more better. So explanatory factor analysis is actually used in developing new factors with a particular set of variables that you already have. So once you have a variables, you are now able to know, okay, all these variables are belonging to a particular group, and these other variables are also belonging to a particular group. So about the World Happiness Report. So the World Happiness Report is actually a publication of the Sustainable Development Solution Network. So maybe at the end of the webinar, I'll drop the link to the publication. I can just Google it, the World Happiness Report. And it's actually a review of the state of happiness around the world. So what they're just trying to see is in summary, they want to see how happy are people, individuals around the world, which country is the happiest country, which country is the happiest country, and which country is, let's say, less happier. So things like that, and try to see what is contributing to an individual's happiness in each country. So the data is actually comprehensive data. And if I can still recall, I think the publication started in 2012, something like that. So it consists of observed data on GDP per capita. So the variables that they're actually using in the World Happiness Reports to know if someone's happiness is GDP per capita, and they also have social support. So how supportive is okay, let's just put it like the social support of an individual, the amount of social support that particular individual is receiving. We have healthy life expectancy, and we have freedom, and that's freedom to make life choices, and we also have generosity. And I think we have corruption also. So there's actually a variable called corruption. So this corruption actually measures like, okay, what's the person's perceptions of corruption, that particular individual or that particular country's perception of corruption, the average perception of corruption in that particular country. So this is actually the dashboard of the World Happiness Report. So you can see also this on their site, and also it allows you to interact and also view happiness in various countries, and also view the variables, and also see which country is actually happier. We have also have what you call a happiness score, a ladder score. You can see it. Those are above 6 to 8 are happy. You can see those 4.5 to 6 average, and also have this. So all these are on their site. You can try to explore these and also read the publication to know more about the World Happiness Report. So in this particular session, we'll just be using structural equation modeling to just see, okay, what's, first of all, we want to know inside the data, how many factors can we get from these 6 variables? That is why I'm bringing in explanatory factor analysis. Then from there, we now perform structural equation modeling to now see, okay, these variables of these 2 factors we have now, how can they measure happiness? So how are they affecting happiness? And also even the observed variables, how are they affecting happiness? Because one thing with structural equation models is that it also combines regression techniques. So you're also able to know how does each particular variable affect happiness, or how does it affect its factor, then it also affects happiness. So now I'll be going into R now to start the analysis. So stop the sharing. So I don't know if you are viewing my screen. Okay. So before I continue, is there any question based on what I've already explained earlier on? Okay. So now let us just start. So for us, these are the libraries we are going to be needing. So the package that's actually used for running structural equation modeling is the Lavan package. So this is it, library Lavan. We want to load it. And we're also going to make use of the tidyverse functions. Then we have readxl for reading in our data. So though we might not be needing this. Then we have psych library. This is used for performing explanatory factor analysis. So that's why we're also needing the psych package. So we're going to be loading in our data now using the read.csv function. We're going to be loading in the whr.csv data. So I'm going to just run this particular line, and you can see that our data has already been loaded. So before I want us to view the data, let me just run this particular code, because this is renaming it based on the main data. They actually give it some, okay, let us just view the main data, view whr. Okay, so this is our main data, and I can see that we're having country. This is like a combined data, because most of the times it's like a yearly data. So you can see the data of 2008, you can see that of 2009. So under 2009, you see for each country and the details. But this is more or less like a combined data. You can see we have Afghanistan here. You can see also have the year column. We also have the life ladder. So this is the average life ladder for that particular country. And we also have the GDP per capita. So most of the variables here are not actually the 6 variables. So there's a combination of other variables, because it's like they're making a publication from this data. So, but we were just interested in 6 variables, which is the GDP per capita, which you can see it here. This is GDP per capita of a particular country at a particular year. Then we have social support, the average support received by individuals in that particular country. We also have life expectancy at death. We have the freedom to make life choices. We also have generosity. This is also generosity. And we also have the higher the value, the higher the individual generosity. Also have perception of corruption of an individual's average perception of corruption in that particular country of individuals. So the higher is it, the higher the country's perception of corruption. They also have positive effect and negative effect. So these are not actually among the variables we are treating. So you can actually go to the publication. You're going to see a deeper study on most of these variables and what they entails, and also countries with the higher variables for each particular year. So these are the variables we are going to be talking about. Now I'm going to be renaming these variables, because you can see that the names actually are long. So I'm just going to be shortening it using the rename function that's under dplyr. So I have life ladder. I'm going to be naming life ladder as LL. I'm going to be giving GDP per capita, log GDP per capita as GDP. social support as SS, and healthy life expectancy at birth as LE. Also have freedom to make life choices as FLC, and we have generosity as GN, percentage of corruption as PC, positive affect as PF, and negative affect as NF. So though we won't be needing this positive and the negative affect, so this just selects the columns which are going to be interested in. So you can see that I've already removed column 1 to 3, column 10, and also column 11. So if I'm to run this now, okay, I haven't loaded this. I'm coming. So I'm supposed to have loaded this since. Okay, so I've already loaded it. This is the filtered data. So let's view it now. So you can see it now. These are the main variables that we're now dealing with inside this. And we also have missing values. So this is one interesting thing with structural equation model. It doesn't care if you have missing values. It still gives you the value the model you want. So it is not sensitive to missing values. So unlike other statistical techniques. So now you can actually use this. Just check on our variables and check for missing. You can see that under the scheme R package allows you to check a descriptive about your data, give some descriptive information on your data. So you can see that our GDP is having 20 missing values. You can see our social support is having 13 missing values, life expectancy 54, and we have this is freedom of life choices 33, generosity 73 missing values. We have this is perception of corruption, I think. Then 160 missing values. You can also see the mean, you can see the standard deviation, you can see these are quartile ranges. You can see all this information. So you can see a histogram just showing you how the values are distributed in each particular variable. So now I already know, I've already gotten a descriptive information about our data. So now is to perform the explanatory factor analysis. So the explanatory factor analysis is where we now fish out the factors which we know our data is grouped into. So now we'll just assume that we have no study that is assigning our observed variables into various factors. So we'll just say that, okay, we don't know the factors that we are dealing with in this particular data set. So first of all, before we perform an explanatory factor analysis now, we need to we need to divide the data into two. So the first part of the data, because we already have our data now. So I think, let me check the dimension of our data. I think dimension. So we have 2,199 rows. So now this particular data now, we're going to be dividing it into two. So one part, we're going to use it for the explanatory factor analysis, and the other part, we are going to be using it for the structural equation modeling. And that why we are doing this is because we are trying to prevent overfitting. So we don't want to use the same data that we are using for explanatory factor analysis and also use that particular data for structural equation modeling. So which means now that there is no information that's going to be leaked when we are performing the structural equation modeling. So that's why we're using two. It's still the same data, but we are dividing it into two. We are splitting the data into two. One part is going to be for explanatory factor analysis. The other part will be for structural equation modeling. So now for us to divide the data set into two, first we already have to store our rows, which is this particular value, 2,199. So that is why you can see we're assigning n rows of the data to the variable n. So we're going to run this. Then we also have indices, which is the sequence from 1 to this particular value, which is 2,199. We're also going to be running this. So now we are going to be splitting indices EFA and CFA. So sometimes CFA is usually exchanged with an SCM. So you can exchange it with SCM. Even the functions, they also perform the same thing. When the CFA function, also the SCM function. So indices EFA now is going to be the indices for explanatory factor analysis. So we're going to be dividing this particular number of rows, the number of observations in our data by 2. That is why we're having 0.5 times n. So the case where we have a decimal figure, this floor is just going to give us, it's going to like round it up. So if we're going to say 0.5 now times our n, you can see we have 1099.5. So by saying floor of this particular value now, 0.5 times n. So you can see what you have already done. So it just truncates it for us. So not rounding it up, it truncates the value for us to 1099. So now by the time we are to run this now, we have already gotten the floor now, which is this particular value. They will now say indices. So you can see indices, this particular variable that we created earlier on now. So I'm going to be running a sample based on this particular indices. It's going to give us a sample based on the indices and this the index of the explanatory factor analysis. So when I run this now and I call indices EFA, okay, sorry. So you can see that we're already having what? A sample of what indices. You can see that this sample, when you look at it now, you can see it's not actually, okay, let's go to the beginning now. You can see it's just like a random, it's giving us random index. So what I'm telling you to do for us is that it should give us random index from 1 to what? 0.5 times n. So it should just give us a random what? Index. And the same too when we go to indices EFA also. So this is our whole indices now. So out of these indices now, we got that of the explanatory factor analysis. While for the CFA now, we are going to be getting indices that we should get indices from this particular main one that are not what? This one. So that is why we are saying indices not in indices EFA. So that is to get the indexes in the indices of that of what? CFA. So which means that the indices of this and this all together will give us our whole indices. But this one is going to be what? Different from this. So we are going to be subsetting our data based on this particular what? Indices. So when I'm going to subset indices EFA of the data, I'm going to get the data we're going to be using for the explanatory factor analysis, which is this particular line. So I'm going to run this now. And when I run view, you can see it now. This particular, you can see that this particular data set is for the explanatory factor analysis. Okay, sorry, it was actually that of EFA. EFA. Okay, so this is it. So you can now see the indexes now. That you can see that they are what? They are not matching because these are random. These are random numbers that were already selected. Because we're just selecting it randomly. Select the explanatory factor analysis data randomly. Select that of the structural equation model also random. So now I'm also going to run for that of the CFA. Okay, I'm not run this. You know, I also run that of the CFA. So if you also view that of the CFA, so you can also see it is also showing us random what the values. You can see it's also showing us what random are values of this our data. So now we already have the data set for explanatory factor analysis, and we also have the data set for the confirmatory factor analysis or the structural equation modeling. So you can see that we already have 2 of them here. So now we are going to be now grouping. We're going to use the indices we created earlier on to create a grouping variable. So we're creating a grouping variable so that we're going to identify, we want to create another column here that's going to tell us that, okay, this particular one is for EFA and this particular data is what CFA. So now we're going to create a numeric vector. You can see it's a grouping variable. This is a vector which the rows of our number of observations in our data. So when I run group variable, when I run group, can see it's showing us what's empty 0, 0, 0, 0. But if we check that the number of elements inside this particular vector now is going to be the number of observations in our data. So now this grouping variable now we're going to be saying, okay, we're going to be using the indices of the explanatory factor analysis. inside this particular grouping variable and give it value of 1. So when you run this and you check for the grouping variable, if you check inside the grouping variable now, you're going to be seeing some values that are having 1. So this is for the EFA. And also when you run for that of the CFA, when you check the grouping variable now, you're going to be seeing that what we're having what 1s and 2s. So which means now that EFA 1 signifies EFA and 2 signifies CFA. So we're going to be using our cbind to bind this particular vector with our data. That is our whole data, which is WHR. So I'm going to be saying cbind WHR, then with what? The grouping variable. So we're going to now have what? WHR grouped. Let me just use the view. So you can see our WHR groups now, which we're already having here. You can see it 1, 2. So you see anywhere we see 1, we know it is for EFA. Anywhere we see 2, we know it is for CFA. Okay, now we've already grouped that particular, data now. So now the first thing I want to do now is to perform my explanatory factor analysis now. So before performing explanatory factor analysis, we need to calculate the correlation matrix because we are trying to know the number of factors that we can get from our observed variables. So we're going to be calculating a correlation matrix of the EFA happiness reports, and we're going to be using pairwise complete observation method. So when I'm going to run this now, I'm going to store it in the variable EFA correlated or correlation. So you can see now I've already run it now. So when I'm to call it, let's see the values under it. So you can see the correlations that we're having under this particular. So you can see the correlation now. You can see that GDP and social supports are correlated with a value of 0.68. So this is a strong correlation. You can see GDP and life expectancy also have a strong correlation of 0.8. We also have a low correlation between GDP and freedom of life choices of 0.3, approximately 0.36. You can also see that GDP and generosity you can just say this is like a no correlation because the value is almost 0.0, approximately 0.02. And also have a negative correlation between perception of corruption and GDP. So this signifies that if perception of corruption increases, GDP is likely to decrease. That's why we're having a negative value of minus 0.35. So the same explanation also goes for other values as you are seeing it. So this is just a correlation value. This is just a correlation matrix between our observed variables. So here we're able to see which value, how is a particular observed variable affecting another observed variable. I can also see where you're having negative sign, especially if it's you can see the negative signs is signifying that there's a negative relationship between those two variables. So in correlation, any value we have above 0.5 is signifying a strong, or let's just above 0.67, signifying a strong correlation, while values also that are below minus 0.5 is also signify a strong negative correlation. So anytime we have values close to 0, we can say that the variables are not having, they're having 0 correlation or no correlation at all. So we have what we call eigenvalues. Eigenvalues are what allows us to be able to select our factors. So eigenvalues actually explain. So what this actual eigenvalues does is that it explains the variance of each particular factor. So it just gives us some factors. The eigenvalues give us some factors, and we're able to see from those factors the amount of variance that that particular factor explains for this particular data set. So now we're going to be calculating the eigenvalues for EFA correlation. This is because that's where we need to get to the correlation matrix. So we're going to calculate the eigenvalues for this particular correlation matrix. It's going to run this. And now we're going to be looking at the eigenvalues that we're having. So you can see that this is the eigenvalues that we're having. So most of the time in literature is you actually select factors with eigenvalues above 1. So any factor that is having eigenvalues below 1, you drop it. So which means These are the factors that are going to be explaining our data very well. So imagine I've added another factor here, having maybe 2 point something. That means I'll be having what, 3 factors. So what this explanatory factor analysis has already concluded for us is that we have 2 factors inside the world happiness report. So which means our observed variables all fall under the category of 2 factors. They either fall into 1 factor or into another factor. Now, naming those factors or giving names to those factors depends on you. Okay, what do you want to give these particular factors? It depends on your domain knowledge. If it's your area of expertise, like, okay, from what I know now, these factors and these observed variables, I can give them this particular, or classify them under this particular group. While these other factors, I can also classify them under this particular group. So another better way of getting our eigenvalues is by using a scree plot. So this is a visual representation of your eigenvalues and also your factors. So when I run this now, you can see our scree plots. You can now see that this is showing us, this is 1 here, just like I explained earlier on. So telling us that values below 1 are not to be selected as factors. So this is going to be our factor 1, and this is going to be our factor 2. And from look, this one explains more of our data than even this other factor because of this particular eigenvalues. Consider this one having an eigenvalue between 1 and 1.5. So which means that the variance, it explains around let's say 1 point something variation of our data, and also have that other factor 1 having eigenvalue of 3.0, also signifying the amount of variance it explains in the data. So it's just common sense. We know that those below 1 don't explain much of our data, and we cannot use them as factors. So we have 2 ways now of either just get the eigenvalues, or we even use the scree plots. Most of the times it's best to use the scree plots. So now I'm going to be running the EFA now with 2 factors. So this is going to be 2. So I'm going to be running the EFA now with 2 factors. Since we've already known that we're having what 2 factors in this place. So I've already gotten a number of factors. Now let's run the explanatory factor analysis using our 2 factors. So I'm going to run it now, and I'm going to be getting our loadings. So these loadings now explain to us what each particular observed variables, which factor do they belong to. So you can see our first factor now in this place, and you can see our second factor now. You can see that GDP belongs to the first factor with a value of 0.986. You can also see that social support is even present in 2 factors, but we have to pick the one with the highest value, because the one with the highest value means that that factor, it belongs to that factor more than the other factor where it is having a lower factor loading. So that is why you can see, even though social support is having 2 values in both factor, we'll just say that social support belongs to the factor 1. Then we also have life expectancy, which also belongs to the factor 1. Then we also have our freedom of life choices, which belongs to factor 2. Now we also have generosity. It belongs to factor 1 and factor 2, but I tell you that we're going to be carrying the one where it's contributing more. So we're going to be carrying 0.592. Then also have percentage of corruption, which is also under factor 2, which is minus 0.590. So from this now, we already know that GDP, social support, and life expectancy and generosity belongs to factor 1. Why social support? We have percentage of corruption, GDP, social support, and life expectancy. These 2 belong to factor 1, while freedom of life choices, generosity, and perception of corruption belongs to factor 2. So now this is what we have already done our explanatory factor analysis now, and we now know which factor and which factor do they belong to. But sometimes you already have idea of what the factors are, so you don't even need to perform an explanatory factor analysis. You just go ahead and start performing your structural equation modeling. So now let's get a summary of our explanatory factor analysis model. So you can see we have various summary. So we have the chi-square. We have but most of the times the measurement indices we use are the RMSEA, and we use the root mean square of the residuals. We have the Tucker-Lewis index, which is 0.916. We have the RMSEA, which is 0.117. And we have the BIC. So the BIC is usually used when you're comparing 2 models. So the models with the lowest BIC, you select it as your best model. So we have BIC as 36.46. So, but a good RMS usually falls around below 0.05. So we cannot conclude because this is just an EFA model and not our main structural equation model. So we also have other indices in this place. So now just the main thing of the EFA is just to get our factors, which I've already gotten now, as you can already see it. So most of the times, if you already have a CFA conducted by someone already before, you can compare your model and also run a CFA model based on that person's theory. And the model with the lowest BIC, you select that as your particular factors. So if one model is telling you that, okay, you can actually get 3 factors or 4 factors from the World Happiness Report, then you compare the model BIC of that particular model, maybe it is 50 something, and yours that is having 2 factors is 36.46. So which means I'm going to go with yours since it has a lower BIC than that other one having a higher BIC. And if the case is otherwise, where the other model is having a lower BIC, you go with that other model and you drop your explanatory factor analysis, which you have already conducted. So now the next is the structural equation modeling. So when performing a structural equation model, we have to, first of all, give the theory of the relationship between our variables. So the relationship between the observed variables and also the relationship between the observed and the latent variables. So this is where this is what we call the model syntax. So you can see the reason why we conducted the EFA earlier on was because we want to get the factors which we have. So this particular model syntax now, we are having 2 factors already. You can see GDP, we have social support, and we have life expectancy. So you can say these are the variables of that variables under this particular factor 1. Then, so this factor 1, we can actually give factor 1 and just say, okay, since we have GDP, we have social support, we have life expectancy, we can just say these are, let's just say, you can just say these are socioeconomic variables. You can just call it socioeconomic or something like that. And we also have factor 2, which is freedom of life choices, generosity, and perception of corruption, which falls under factor 2. So based on your domain knowledge, also you can also give what do you think this particular tariff observed variables can fall under. Because at the end, it's these 2 factors that are going to be letting us, that are going to also be predicting happiness for us. So now this model syntax now I've already done. This is just a simple model syntax. So we're going to come later to be editing it to improve our model. So now we're going to highlight this. I'm going to highlight this and run the model syntax. So now the next is our measurement model. So the measurement model is where we use the same function. So this same function is going to perform the analysis on our model, on our data, and also using the modeling syntax we defined earlier on. So this model syntax I already told you is where we define our relationship. So now the same function only takes the model syntax and the data, the necessary arguments. So once you are done with this, you are able to run this. You run this and perform your same analysis. So now I've already performed the same analysis. So sometimes we get some warnings, but you can ignore the warnings. And we are going to get our summary now, which is our measurement model. So under this summary, we are going to be giving the parameters of fit measures equals to true. So we want to see our measurements fits, the measures that we're going to show us our model fits. They're also standardized as true. So when you run this now, you get the results of your structural equation modeling, which you can see now. So what allows you to know that your model is a good fit are these values. You can see them. We have the CFI, we have the TLI, we have the this one is for when comparing 2 models, the BIC. So we also have the RMSEA. We also have the chi-square, but most of the times we don't use the chi-square because the chi-square is actually sensitive to extreme values. So if you can see that the chi-square now is returning that it is not significant. So cases will be where your model is not a good fit and the chi-square will still be telling you that it is not significant, it is significant, because when it is significant, it means that your model is a good fit. So cases will be where your model is not a good fit, but because you have high number of observations or high number of samples, then your chi-square is going to be telling you that is actually your model is actually significant. That means you're having a good model fit, whereas you are not having a good model fit. So for the CFI now, the CFI number is 0.941. So a good model is going to be having a CFI above 0.9. And also a good model will be having a CFI above 0.9, a TLI, that is Toka-Lewis index, above 0.9. While the RMSE also, a good model is going to be having a value below 0.05, and also have the standardized root mean square residual, which is the SRMR. A good model is also going to be having a value below 0.05 also. So which means that based on this model now, we also have a lot of improvements to make in this particular model. But how do we now make improvements into this model? So this is where this particular, you can see, we have a...
Hello.
Yeah.
Hello. Okay. Sorry to cut you in there. So I was actually raising my hands. We have a question in the chat, which I would suggest you take before you go further. So we have Ahmed Abi Wessam. I hope I pronounced that well. He's saying that he's not completely clear with hygieine value and their factors. So maybe you should elaborate more on that.
Okay, so I told you that the eigenvalues, so the eigenvalues is actually values calculated from a matrix. So that's why I told that we need to have a correlation matrix earlier on. That was why we created a correlation matrix. So you cannot have the eigenvalue without having a correlation matrix. And you can also, these eigenvalues, the eigenvalues are actually like, they actually explain, these are values that explain the amount of variance that is explained by each factor. So the number of eigenvalues you have is the number of observed variables you have. So if we have 7 by 7, we're going to be expecting eigenvalues of 7 numbers. You can see that we're having 6 observed variables. That's why you can see we're having what? 6 eigenvalues. If we have 7 observed variables, we're going to be having 7 eigenvalues. If we have 8 observed variables, we're going to be having what? 8 eigenvalues. So this is just like for each particular variable, what is the eigenvalues? But this is, we have to have a matrix, which is a correlation matrix, to now calculate that particular eigenvalues. So now when we now go to the values of each, the eigenvalues, you can see that each of them is like a factor. It's just like telling us that, okay, these eigenvalues tell us that, okay, these are the number of factors you have. But for you to select a factor, the eigenvalue needs to be above 1. So now 2.9, this particular eigenvalue now means that we already selected a particular factor. Since it is above 1, so it explains what the variance is, just like saying that the variance of that particular data now based on this factor is 2.9. Why for this next eigenvalue is approximately 1.35. So which is means like saying the variance of this factor regarding the happiness report data is around 1.3 But you can see that the rest are below 1, which means that we cannot make use of this. If possibly we had eigenvalue of all of them above 1, then we can now say that we have 6 factors inside our world happiness report data. But since our eigenvalues, we only have 2 above 1, it is telling us that we have 2 factors inside this particular world happiness report. All the variables fall under this particular 2 factors. If it was 3 values that have eigenvalues above 1, it is telling us that we have 3 factors inside this particular world happiness report data, which means that all our observed variables, that is 6 of our observed variables, are falling under this particular 6 factor. They either belong to one factor and another factor and another factor. So that is what the eigenvalues is all about. It's all about getting the number of factors you have inside that particular world happiness report. So eigenvalues above 1 are what you now select to be your factors. So if you're having 4 now above 1, then you have 4 factors inside your data. So I don't know if it is clear.
Yeah, thank you. It's clear right now.
Okay, thank you. Okay, so now earlier on, I said we calculated we've already calculated our model fits. So I've already explained most of this, but we want to improve our model. So this is where we're now going to be using modification indices. So modification indices allows you to show, it shows you what can you use to improve your model. So the name of our model actually was, let me see. Okay, let me just remove this. Our model is actually MEA model. So this was the object. This is the object storing our model, and we're going to be using the argument dot sort is equals to true. We are going to do sorting the modification indices. So when you run this now, okay. Okay, I think, let me see. Okay, sort dot, it's also the sort dot. Sort dot, not sort. Okay, so now, okay, let's just remove this sort for now and let me show you. Okay, so this now you can see this is our modification indices. So what this is telling you that it is showing you where you can improve your model. So this sign that I are seeing here, it means what? Observed variables to latent variables, which means that what? These observed variables are measuring this particular latent variable, which is our factor. So that's our F1 that we have earlier on. And you can also see these particular observed variables are also measuring this latent variable, what? F2. Now, we also have the sign, the regular sign we can have where we have just this. So this is just like our regression. We can say, let's just say FLC. You can say generosity, which means that what generosity is predicting what? Freedom of life choices. So this is our regression what symbol. I also have this means correlation or covariance, where we have what? Double tilde in a covariance with generosity. So now going back to our modification indices now, it is showing us that where can you and what can you use to improve your model. That is where we use this MI. So the value of the highest MI, you go back to your model syntax and give it. So this is where we'll now go back and put our sort dots is equals to true. We want to see the value with the highest MI. So you can now see that the value with the highest MI is what? F1, that is the observed variable generosity on the latent variable of factor 1. So you can see it, which means that what? Generosity belongs to factor 2, and we also have to include it into factor 1, so that we're going to get a higher we are going to get a better model fit. So now I've already included this now. We're now going to run this. Let me just highlight all and run it again. So we go back now to see what values are we having. Can you see that our model fit has already improved? So earlier on, we're having 0.8 something for here. You can see that we're having 0.937 under this place. Then we can also see that we're having our RMS here 0.103 and our SRMR 0.031. So we need this to be less than 0.05 and also need this to be less than 0.05 also. So which this is already matching. So that means that we also need to add more things into our model syntax to improve the model. So we're going to go back to our modification indices. So we're going to go back to the modification indices now and run it again to add the covariance between social support and freedom of life choices, because this is having the highest modification indices of 45.687, which means if we have this, we are going to have a better model fit. So now let's go and add this social support and freedom of life choice. I'm going to go back now and add the covariance between social support and freedom of life choice. So by adding this now, I'm going to run the model again. So this is more or less like a repetitive process. You have to make sure you are running it again to check until you are satisfied and you know you already have a good model fit. So I'm going to run this again. So you can see that these are also improving. It is 0.99 now. I also have 0.975. And also go back here. You can now see that the RMS here, because we want it to be less than 0.05, you can also see that already improved now. So from 0.1 something is already 0.065. Well, you can see our SRMR is also around 0.019. So we still want to improve it. We want to meet up with less than 0.05. So we're going to go back to the modification indices and also run it again. Now it is telling us that we need to give the covariance between life expectancy and freedom of life choices. before we can be able to improve the model more again, because this is the one having the highest modification indices of 19.315. So I'm going to go now, life expectancy and freedom of life choice. So I'm going to go back and add it, life expectancy and freedom of life choice. So I'm going to highlight this and run it again. So we can now see now that we have what 0.037 and 0.014. So this now we are going, this is already less than 0.05, and this is also less than 0.05, and this is above 0.9. This is also above 0.9. The CFI is above 0.9, the TLI is also above 0.992, 0.9. The RMSE is below 0.05, and the SRMR is below what 0.05. So now we can go with this particular model, and this is going to be the final model syntax. You can see that from this model now, we have already arrived at this. Based on your choice, you can also go back to the modification indices and also check if you can still improve the model more or not. So we're going to be stopping there in adding to our, we are going to be stopping there in, we are going to finalize our model syntax based on this syntax we already have specified here. So we can see that what generosity is both in two factors. We can also see the that social support is having a covariance with freedom of life choice, and we can also see that life expectancy having freedom a covariance with what freedom of life choice. So now let's go to now interpreting our model, and what do we have? So you can see now under this place now, we have estimate, we have standardized error, we also have our p-values, and we have standardized all. So most of the time, this is what we actually use. We use the standardized all. This is the standardized values. So, or we could say the standardized factor loadings. So factor loadings is going to explain to you how that particular variable contributes to a factor. So let's just say for this webinar purpose, for example, now, we have GDP, we have social support, and we have life expectancy, we have generosity. So let's just classify this factor one. Let's just call it social. Let's just say it is social economic. Then we have freedom of life choice, and we have generosity. We have perception of corruption. You can also just call this as you can just call this. Let's just say you can call this as a factor which you can actually give. Okay, let's do it like this now. We can actually just classify this F1 as socioeconomic, and we can actually just classify this into, let's just say, to the psychology, since this is talking about generosity, freedom, and perception. But just say the psychology of the individuals in that particular, and just give it this particular two factors, psychology, and we can call this socioeconomic. So we can now say that, okay, GDP is actually contributing to this particular socioeconomic factor by 0.985. So it is having the highest factor loading. And we can also say social support is also contributing by 0.705. We can also see life expectancy is 0.85, contributing by 0.85, and also have generosity. So what allows us to know if these particular observed variables are significant or not is the p-values. So if this p-values is actually, let's say, is actually greater than 0.05, then we can say that it is not significant. But since less than 0.00, this means it is what? Significant. So now, based on these particular variables, now we already know that all of them are significant in contributing to our factor, which we have already called as socio-economic. And can also see that generosity from this place now, it is telling us that we're having what's the negative 0.2384 generosity. Then also when you go to the second factor, which we are just saying, we're calling, assuming that psychology, which we have freedom of life choices. It's also contributing high with 0.698. We have generosity, which is 0.568, and we have perception of corruption, which is minus 0.676. We also have the covariances of these particular observed variables. Then also have what the variances, which you can see for this particular observed variables. Variances, which we specified earlier on. You can see this particular covariance between social support and freedom of life choice. It's telling that there's a significant relationship between them. That is why we put it inside the model. You can also see that of 0.062 is for that of the factor 1 to factor 2. We also have life expectancy and what freedom of life choices. So this is it for, you can actually also extend the models in various ways by actually specifying regression model, which we not actually do inside this particular model. This is already okay with the model fit which we are having. So that the next thing is also to draw the path diagram. So the path diagram, you actually have to install the package semplot. Then after installing the package semplot, you load the package semplot. So after loading semplots now, they can now use the same path function. So normally the same path function, if I just say same paths of our MEA model, which just defined earlier on. Then I'm run this, load it, and okay, so these are same path function based on our model. You can see it's also showing us a diagrammatical relationship between the latent variables, which are represented as what? Cycles, and the observed variables, which are represented as a square. You can see them, or rectangles most of the times. So you can now extend this to now what gets what more. Like now you can also change the layout. We have, you can change the layout of it. Say layout is equal to 3. Okay, this is actually 3 layout. I think it's actually cycle, or I don't know if it's a cycle. Okay, you can see a circular layout. You can see how the circular layout looks like. So most of the times, most of the times the 3 layouts is usually used. So this is the 3 layouts of your SCM model. Then we also have their rotation. We have a lot of parameters under the same path, but most importantly, the important ones are the what labels. What do you want your labels to be? Because you can see currently we're having no label. So it's going to be our standardized factor loadings. So it's going to be our labels. You can see it now. You can see the amount that a particular observed variables contributes to each what factor. You can see the amount of particular observed variables contribute to what each factor. You can see what we're having 0.85 for, you can see for life expectancy, you can see for each particular what factor. They also have what we call edge.color. Edge.color. You can just say edge color is going to be red. So you can see edge of color is going to be red. It just colors the lines that's connecting your latent variables and your observed variables. They also have another parameter called watts. So what actually does is that it's just sticking the lines based on the strength between each observed variables and the latent variables. You can see life expectancy and factor 1, because it's having 0.85, is having a more thicker line than that of social support. You can see 0.982 also for GDP. It's even thicker than the rest. You can also see that of generosity and factor 1 having a lighter line. You can also see for that of the factor 2, which we're having in this place. So this is it just for performance structural modeling. It's very easy in R. It's just, you can just say it's like a 4-step approach. First of all, just have to define your model syntax. You don't need to worry about your model syntax. You can just define a simpler ones, and you can end up using your modification indices to improve it later. You can use your modification indices to improve it to improve your model later. So based on the values you have from your modification indices, you use it to improve your model. So that's going to be telling you that, okay, this is where I'm going to improve the model to make it better and things like that. So in summary, you just define your model syntax, which you just did now, and their structural equation modeling, which we just performed now, and also our summary, then our modification indices. Then also we can plot our same paths, so you can see it now. So for the 2 factors that we're having, so between these 2 factors, they're having a correlationship of 0.53, which means that they are strongly correlated between the 2 factors. So these 2 factors we just used, for example, socioeconomic and also psychology. You can see that the generosity, the freedom of life choices, and perceptual corruption falls under psychology. So this depends on your domain and because it's like you're classifying or you're creating new factors for these observed variables. So this is what it looks like. Another study has already defined other factors which these observed variables falls under. So I don't know if there's any question.
Okay, I think looking through the charts, we don't have any question there. So if you have any question, you might signify and unmute, then we can join the discussion now. Okay. Okay. So if you have any question, you can go ahead, unmute yourself, then you ask the question. Okay, once again, the recording of the webinar the meetup is going to be available on our YouTube channel. So we'll share them with you. So you'll be able to get them. Hopefully the next few days, we'll be able to share it with you. So, as well as the script. Yeah, the script, the slides, everything is going to be shared with you. Yeah, everything. So if there are no questions, okay. Yes, we're going to share the code as well as the data. Everything is going to be shared with you as well as the recording of this webinar. So I hope that's clear, Justin. Thank you. Thank you too. Okay.
Thank you, everyone.
So at this point, I want to appreciate Ridwan for his time and sharing his knowledge. We're really grateful for that. So, and also we want to appreciate all of you that you've joined us from all part of the world. We're grateful and we look forward to seeing you next time. So thank you and God bless. Thank you. Thank you, Ricardo.
Thank you, everyone.
So thank you, Ahmed, Justin, Felix. We're grateful for your time. Thank you, everybody. So till we meet next time. Bye.